Hi guys, I've got a Hewlett-Packard all-in-one PC here for repair. Customers brought me this one in. Actually, another business brought me this one in who's now selling laptops and these sort of things, and he says, can I fix it? So it's got a power supply with it, and he says basically it's completely dead, so could be the power supply, could be the unit, I really don't know. So yeah, let's see if we can fix this one. I'll try not to say that Y word so often as people have commented on. Yeah, oh sorry, there it goes again. I'll do my best. So let's plug the power supply in. What is it? It's probably like a laptop power supply, they usually are. Must say on there somewhere. I'll probably need a magnifying glass. But anyway, let's not worry about it right now. Let's see if this actually is working, or is it? I'm assuming, as he says, it's completely dead. Yeah. So let's zoom the camera out a little bit as well if we can. So it's plugged in, and there's like a little on-off switch under here somewhere. Here, but nothing's happening. So, well, we can say the owners correctly identified the problem with it. Yeah, it's dead. So, first and obviously the most obvious thing to do, yeah, is see if the power supply is working first. So let's have a look at that. And obviously this is not like testing it under load, but it might give us some indication if anything's coming out of it. So let's have a look here. So we'll just go on here. Is it the middle pin or is it the inside pin? Well, basically, from what I can see, there's nothing coming out the power supply. I'll switch it off. I mean, I've done that in case there's like a short or something inside here, so effectively causes it to shut down and stay shut down. Yeah. So that hopefully might be long enough. No voltage there. Now I'm not sure if it's a centre pin or that pin. There's like two pins inside here. I can hear this sleeve type thing. Let's have a look. Oh yeah, okay, so it's now got 20 volts on it, near enough, yeah? And when we plug it into the unit, and then unplug it again, has it gone off? Yeah, so it's like there's something in here that's either drawing too much current and this is shutting down and staying shut down, or the alternative is that this is just failing when you put a load on it and it's shutting down. So we need to figure out that, don't we, really? So let's think how we can do that. Okay, so this is a plug cut off an old power supply. It's actually, I bought somebody needed like a 6.5 amp laptop charger power supply, and this didn't have the correct end on, but I had the correct ends, so I effectively cut this off the good power supply and put the end on that the guy needed for his laptop, and it was working. Yeah, that went into like a ROG Strix gaming laptop. So the outer part of this, like the outer part here, which is the negative, because I was measuring the voltage across it, that goes to the black wire. Yeah. Now if you look inside, there's like a centre pin. Yeah, probably there's a centre pin and like another sleeve on the inside of this. And I'm sure the other sleeve on the inside goes to the white, yeah. And then the centre pin, I'm sure it goes to the blue one. And I think that centre pin basically is kind of like, it measures the voltage at the entrance to the laptop, and then it effectively allows the power supply to increase or decrease the voltage to allow for any current drop on the cable, yeah. But we can use this, so I can put this into the back of the all-in-one. I can take my bench power supply. I've had a look at the specification for the power supply that comes with it. It appears to be not dead, but it's, you know, dropping its voltage, and it's a 3.3 volts 3.3 amps 19 volts. So I can actually use my bench power supply. So the bench power supply, I can set it so it goes up to 5 amps 19 volts, no problem. And I can connect the positive to the white and the negative to the black, and then I can test it. So I can power it off the bench power supply, and not only will I see if it actually works or not, but I'll also be able to see how much current it's drawing. So I'll solder a couple of wires on here, put a bit of heat shrink on just so you don't short out. And let's get the bench power supply and see what's happening. Because the wires are so short, I was struggling to get a bit of heat shrink sleeving down here. So what I've done is, this is like a 2.2 mega ohm resistor. So you effectively hit 19 volt, that's open circuit, yeah. So I've tagged it across the two wires, which kind of like holds them apart now. So they can't touch each other. And I can now just quite literally clip my leads from my power supply on like so. And I've got power, yeah. So it's just a handy little trick to show you there if you have something like this where wires are shorting, you need a quick way to stop them shorting, yeah. So let's connect these to the bench power supply and let's see what current this runs. I'll set the cameras up so you can see it all. The power supply is set to 19.6 volts, which is close enough. I've set it to deliver up to 5 amps. So the white wire on this, I'm sure, was the one that went to the inner sleeve, so actually positive. And the negative can go on the other side, so that's fine. And we can just check, actually. I mean, there's no reason why we shouldn't have anything other than we expect here. So outer sleeve to negative, inner sleeve 19.6, yeah. So we've got a supply. So what we'll do is we'll just connect this to the back of the unit and then switch it on and let's see what happens. So put onto the there. And straight away it's drawing 5 amps, yeah. Straight away it's drawing 5 amps. I'll switch it off. So this has some sort of short circuit on it, yeah. So what we need to do is open this up and have a look, see where, but it's definitely drawing at me like 5 amps. So there's a short somewhere. Okay, let's get it opened up. I've mostly got it apart now. So I mean, I've unscrewed a lot of this stuff. It's like that little fan assembly. Yeah, I was losing a few bolts in there somewhere while I'm doing it, which was not good. Oh, there it is. I've got them. Okay. So yeah, that wasn't the best of moves. Let's put this where we can down the way. Okay, that's that. Yeah, so I've undone some of the screws on here. It's much like a laptop board, really. This must be the CPU and probably integrated GPU as well. So there's just a number of screws holding all this together. And then hopefully we can get to the other side of this board, see where the power's coming in, and figure out if there is a short and where it is. I mean, it looks like there's a short on this somewhere. Unless I made some mistake connecting up that power lead, but I really don't think so. Find my little, yeah, a little screwdriver. So we get this off here. There we go. Now let's have a look to see if we can actually see a short. Don't know. It looks like it's ready to come out. Don't think there's anything holding that in place now. All the screws seem to be out of it. It's a bit stuck. Yeah, so this is where the power is. Okay, so let's get rid of all this big part and let's have a look at this on the bench and see what we can see is happening with this one. Yeah, so the red cloth on the desk, by the way, was just to stop it scratching the front of the screen while I had the thing face down, working out how to get it open. Which apparently was just, there was nothing altogether, it was just clips all the way around. So this is where the power was coming in. So let's have a look to see if we can see any shorts around here. Sorry, just that view, so that's there, yeah. Let's have a look to see. So I guess it's soldered onto the back here. I can see. It's a bit hard to see what exactly connecting to where. Just go to the middle pin. I mean, unless the middle pin is a positive on this. Doesn't seem to go anywhere. Let's connect the little plug back into it. I'll just take the thing off the bench power supply. Okay, so this is our little plug that we wired up. So this can go into here. Yeah, well, let's have a look at what we've got. So there's a short. Yeah. Those are the right connections. So let's go to, this goes to ground. I don't think the blue one goes anywhere because I'm pretty sure that kind of like pulled up out of the connector too soon, basically. So let's have a look to see on the board itself and see if we can figure out which pin is actually going where. The fact they're both reading effectively short doesn't really help me much here. Let me see if I can just work out where the positive supply should come in. Okay, well I haven't exactly worked out where it is yet, but I'll just get the meter so you can see it and I'll show you what I do see. So you've got the voltmeter there now. I'm on the resistance range with the blip here. So you can see here under this little bit of paper which I might actually remove. This is where the back of the power socket is. Now here and here are two capacitors, and it wouldn't make sense as a short circuit against the capacitors. I'm sure the capacitors, they look like capacitors to me, so that looks like there's a short. Yeah, I don't think I need to desolder the connector to say for certain. There's a short circuit here and that's obviously a problem. I can see on here various buck regulators, 3 here, 1, 2, 3, and another one here and here. I can see like 5 voltage regulators on here, and it looks like there's a short on the input. So let's have a look at these various voltage regulators. I've gone to resistance range. Let's see what resistance we see, because obviously these are all the various voltage rails in here. So that one is just reading high resistance. That also looks like it's reading high resistance. Yeah. And then the ones over here, 3 of them. So to ground, there's no short on there. There's no short on there. There's no short on there. So the short appears to be, if you ask me, on the input somewhere from the main power connector, which is around these capacitors here. That seems to be the, well, there's definitely a short here. Anything we see on the other side of the board? We see some more butt coils, so we'll look at around those. There's lots of them on this actually. So there's another one here. No short on that. There's 2 more up here. No short on that one now. Another one here, bigger one. There's no short on that one. And there's another one here. And there's no short on that one. See, as I'm seeing the short circuit from 19 volts into ground, if there was a short circuit to any of the regulators, you would see it from ground or from 19 volts because there's a short between the two. Another way the capacitor just down here. Yeah, these read the resistors. So obviously I've got a supply for a RAM, a supply for the CPU, GPU, I mean, you know, various supply voltages on here. Some more capacitors here right by where the power comes in again. That looks short. That looks short. What's this device here? Is this a MOSFET? Let's zoom right down, let's see if we can see. Yeah, it's on maximum zoom anyway. So this looks like it's a MOSFET. I've got a short here. It's on the other side of it. Short there. And a short there, if that's the gate. Oh no, that's possibly the gate. So this device appears to have a short both sides of it, which makes me think that's short. Let's get under the microscope now. Let's have a see what that device is and see if we can work out exactly where the problem is with this. Okay, so this device here, TPCA8109. Now that looks to me like a MOSFET, so like 3 drain if you like, 1 gate and 4 on the source. So again, if we just go from ground and we have a look around here, so this is ground. This side is reading short. This would be the gate, you would think, and that reads like a resistance. And this side reads a short. So both sides of this device, I can see this short to ground, which makes me wonder if something's gone short after here and effectively blown this. Let's see if we can find a data sheet, and let's just confirm that actually is a MOSFET. So it's TPCA8109. Yes, that is in fact a MOSFET. I'll just go to the screen, you'll be able to see. So here we go. So this is the data sheet for it. It's a P-channel MOSFET. Yeah, obviously it's like a PNP to NPN. It's different from the normal N-channel that we see, but it's a MOSFET. So that should not be reading short circuit. That's the first thing we can say. I also suspect that is, in fact I know that's not what has caused us to read a short on this. This is effectively acting like a switch, you know, that switches the power in. So neither side of it is actually connected to ground. It's not a buck regulator, I'm sure. And the reason for that is because if I just go back to the workbench again, one moment, yeah, there we go, microscope. Okay, so I don't see any buck regulator coils around here. So I'm fairly confident this is effectively just, you know, passes the current through, should just be turned on, and allows the 19 volts to come into the various buck controllers that we can see near to the coils, yeah, that effectively generate all the voltage rails. So it seems the short we've seen is one side of this or the other side of this to ground, which is not through this itself. Neither side of this would be connected to ground, I'm sure. So I'll remove this first. Let's get us off the board, and then let's have a look to see which side of this the short circuit actually is. But I'm confident that device is faulty. I remove the MOSFET then, so you can see, I'll just get the meter where you can see it again one moment. Okay. While I was doing it, I accidentally dislodged this resistor. I didn't lose it, it just sort of kind of like between here and here. This is the gate resistor, so I've soldered that back into place. I can just be sure that it's actually fitted properly. I'm not sure what value this resistor is, but should now be some resistors to here. Let's have a quick look just to make sure that is actually in place. Yeah, it is. Okay, it's pretty reasonable. And obviously then it'll be short to this end. Yeah, okay, it is. Okay, so we have a look again on here. We go to ground with the black lead. So this is the 19 volts coming in, and there's no short here now. And this is where the short is on this side of the MOSFET. So somewhere in here there's a short circuit. I think the best way to find this one is going to be to apply the voltage from the bench power supply to here and see what gets hot. You know, let's see where the short is. So we'll do it that way. This is our board then. So what I'm going to do is I'm going to inject some voltage here. First of all, I'm just going to put like a safe voltage in, like 1 volt. I'm interested to see what current it draws at that. And then I'm just having a look around on all the inductors which are derived from the 19 volts just to see if the voltage is coming through there. If it is, obviously I've got like a short circuit high side MOSFET somewhere. I've tagged some wires on. I find it easier to do it this way. I know some people just hold the, you know, I use a meter probe connected to the power supply and just hold it in to inject voltage. But I find if you do it this way, you've got both hands free. I just find it easier. It takes, you know, okay, it takes a minute to solder the wires on, depends on how lazy you're feeling versus, you know, how much advantage you think there is to it, yeah, basically. So let's stick our volt into this and let's see what it actually does. So it's drawing, oh, it was a bad connection on there, yeah. It's drawing a couple of amps now, you can see it on there. So there's definitely a short somewhere. Let's see if that's enough to actually get something to warm up on this. I mean, I may need to stick more in than that, yeah. Well, at 1 volt at 2.78 amps, you can assume something in total is dissipated 2.7 watts, but it could be distributed between the cables, the unit. I can't feel anything getting warm at that at the moment. It's kind of wandering around a bit. I think I might just have a slightly bad connection on the lead actually. So, oh yeah, looks like I have a very good connection on the lead. Okay, it's now up to 5 amps. I need to just sort that out, otherwise I'm not going to get things warm up one moment. Okay, so I've got a couple of new leads on it now, maybe some new ones. So I've now got 5 amps flowing into this. You can see the voltage is down to 0.6, but nothing appears to be warming up, and this is the problem you have if you've got an absolute short somewhere. Often you find maybe something over here. No. Let's see if any voltage is getting anywhere else. So we'll go from ground, find a good ground point. First of all, let's see what's voltage is actually coming in. I mean, it's possible a lot of this voltage, a lot of this 0.6 volts is actually disappearing within the leads themselves, because they will have some resistance. But we can have a look, see if there's any voltage actually getting to the board. Yeah, 0.2 of a volt. So 0.4 of the volt is being dissipated in the cables, which tells me this is an absolute short circuit. 0 ohms is near as damn it. Yeah. And the problem with that, with only 0.2 of a volt coming in, and my power supply on maximum at 5 amps, then the wattage is dissipating. Like 1 amp, it would be, sorry, at 1 volt it would be 5 watts, yeah. But at 0.2, then it's like, 20% of that, it's like a watt is being dissipated on the board, and the rest of it's being dissipated down the cables. And I don't think I'm going to be able to find the shorted device. There's no point trying to turn the voltage up any, because I can do, because it won't supply any more voltage because it's on maximum current. There is something possibly down here. Let me see if it warms up after a little while. Well, it's been on for a few minutes now, and I think there's something warm down here. Obviously there's no smoke and it's not very hot, but I think I could feel something down here that was warm. Maybe one of these little capacitors. If I leave a finger on it a little while, it feels possibly one of these is getting warm, one of these here. Let's see if we actually read any voltage across that. I mean, if it's a short, it should have no voltage across it at all. Assuming it's on the same voltage rail, I'll just turn the supply off for a minute. I'll just disconnect the supply. Now let's have a look to see if these here are actually across our voltage. So I'm on the black, and does that go to one end of this? No, it doesn't connect to ground. Make sure the meter's working, yeah, but it doesn't connect to ground. So if it doesn't connect to ground, that can't be short. That can't be the short, yeah. Whatever's short has got to be connected to ground, and that isn't. Yeah, the meter's working. Okay, let's put the voltage back on again, see if I can just find it. The thermal camera would be useful. I don't have a thermal camera. Unless somebody wants to send me one to review. That would be nice. Yeah. Okay, let me get a little bit more. Let's see if I can actually find anything that is warming up on this. Obviously, really here, I need a more powerful bench power supply. If I could stick 10 amps into it, I might get somewhere. And this is the problem when you have a very low resistance short. But if I leave it on a while, it feels a little bit warmer. I use the back of my finger, I can just a little bit more sensitive. In this area, it feels a little bit warmer. Now, I can possibly kind of narrow this down a little bit. So I'm using this voltmeter, which has a millivolts range. So I just set it on to millivolts. It's on millivolts now, yeah. We'll just put the light on. So if we measure the voltage at the point we're injecting it, I'll just get the meter probes. So I'm going directly from where the voltage is coming in, here to here, yeah. and we've got 218.9 millivolts. Now that's going to go all around the board to the various buck regulators. So what I can do is I can look for capacitors in the area of each of these, because there will be input capacitors that are on that voltage rail, and with a bit of guesswork I can probably find them, and I'll find them by finding a similar voltage across them. Yeah, so nothing on that one. Nothing on that one. I might have to get the magnifier, but let's see if I can see it without. Let's see if I find some input capacitors. There's some capacitors here. So I'm just looking for the larger capacitors and see if I can find any that are on this voltage rail around this regulator. No. No, there's one here. Yeah, so that was 160. So that's obviously less than here. So that means there must be some current flowing down the circuit path to there, yeah? If you go down in the area of this, there's some big ones here. Are these on it as well? Yeah, 127. So that's obviously drawing a little bit of current down there. There's another regulator here. So again, let's try and find the input capacitors. Nothing on that. Nothing there. Another one here. 129. So the idea is the one that gives you the lowest reading, that's the area where the problem is. So there's one here, and this is giving 83. And this one is the one that feels somewhere around here like it's just getting a little bit warm, only to the back of the finger. It's not very much so. But there's a few more capacitors. Let me try this one. The whole point of this is that whichever has got the lowest reading is where the short is. That's the lowest I can find so far, 83 on that one. There's maybe something around here I can't really see. Let's have a look on the other side of the board and see if we can find any other likely candidates, but that's a likely possibility. So again, we've got various inductors. Let's try and find capacitors that have a voltage across them. 117, that's higher. 111. These are probably the output capacitors, but nothing on these anyway. Yeah, but that's higher than the other one. The other one was 80 something. So have a look around. There's some more around here. See if we find one again. 160. So it's not in this area. So it would appear that the lowest readings I'm finding are in this area. Yeah, and this is where I may just have a little bit of warmth. So what I'm going to do is now see if I can find which components in this area are connected across the ground. It could be a problem with this chip, but I think this capacitor is just slightly warmer. Is there anything across these? I mean, obviously some will be on the output side again, so they just won't read anything. Oh, no, it's just dropping away. It's like a little bit of charge in the output capacitors, basically. This is the place I can find the most reliable low reading. So let's remove that one and let's see if that is actually the culprit. Yeah, and I'm sure this is getting a little bit warm. Okay, I'll get that removed. Okay, I've removed those two capacitors. I'll just zoom down in this area actually so we can have a closer look at it. Just get a little bit further into that one. There we go. Yeah. So I removed the two capacitors. Can we get this in? Just about. Okay. So let's see if the short circuit is still here. So we'll just check across where the capacitor was mounted. They're in parallel, the two capacitors. And no, we still have a very low resistance here. A very, very low resistance. So it wasn't the capacitor that's causing the problem. Okay, 0.04 of an ohm. Yeah. So again, we'll do the same thing and let's see if we can find anything else in this area. I mean, we know the fault's somewhere down here because this is where we're reading the lowest resistance. Sorry, where we're seeing the lowest voltage on the millivolt range. So obviously at the lowest point of resistance is where you see the lowest voltage. Yeah. So we'll just power the power supply back up again. Just stick some voltage back in. So we back up to 5 amps obviously. Well, let's see again. Let's measure the voltage first. If I get into the shot, I think I can see what we've got. Find the right lead. Yeah, I've got it. Okay. So, millivolts. That's millivolts, DC and AC, millivolts. Okay. So we have across the thing 81 millivolts. Okay. 81 millivolts. So let me see, I'll leave it on for a few minutes. Let me see if this area is still warming up. Okay, it's still getting warm in the same area. So this is directly underneath where I was when I just removed these two capacitors. And this is on the other side of the board, directly underneath. And we have two capacitors here, and this one looks a little bit distressed, shall we say. So this is directly underneath where I was before. So once again, we can take the millivolt meter. Something here is just a little bit warm, the same as I was finding before. I'll just get the other end of the meter probe. So we have these two capacitors here. This is the shot, here we go. So this one shows 82.3. This one shows slightly lower at 80.1. So let's remove that one and see if that's the culprit. Okay, so I've got that capacitor off. Now what resistance do we see across these? There was a short here. And no, there isn't a short anymore. So they're like 1.5 meg now. So the short's gone. So yeah, it looks like we found it that time. Let's have a look at the capacitor that we took off. Let's get it here somewhere. Yeah, it's there. Let's see if we can get this into the shot for you. Stick it on here. Why not? Right. Let's have a look to see if the capacitor's short. I'm assuming it is. Now, fun enough, I don't read the short across it, but bear in mind, I took a lot of heat detectors off the board. And it's quite likely that it's now gone open. So, oh no, I had something there. Where is it? I find it again, I see. I'll just try and get across again. Let's have a look. There. Yeah. There's your short circuit. Okay, so what we need to do now is, I could probably just try it, but let's replace these capacitors. So this is the one that I took off from the other side. The tiny, tiny little one got stuck to the end of the soldering iron basically and disappeared. But this one we can check. So if we measure the capacitance of this one, it's almost certainly the same as the other one. They're both on the same voltage rail after all. I mean, they're probably not even, strictly speaking, necessary, but we might as well try and do the job properly and just replace them. So I'm guessing they're probably somewhere less than 20 microfarads, just to guess. So this is the capacitance meter. The capacitor's in here. Yeah, they're 10. There's neither damn. That's a 10 microfarad capacitor. So I'll put a 10 microfarad back here. I'll put a 10 microfarad back on the other side, which is directly underneath where we were. Just find it. Yeah, here, yeah. I'll put a 10... I've lost the other side of where I was now. Oh yeah, it's over here, top end. So I'll put another 10 microfarad back in here. And then parallel was a tiny little one. So I'll take a guess that was probably 100 nanofarads and put 100 nanofarads in there. And then let's see if this thing actually powers up and works now. Okay, I've replaced the capacitor. This is the one that we took off that measured at 10 microfarads. And I've fitted a 0.1 microfarad, 100 nanofarad if you like, in parallel with it. It is actually in parallel, so I've taken a guess that that is probably a 100 nanofarads. These are fiddly to solder. I mean, these are 0402 as the size of these. They're tiny, so it actually took me a couple of attempts to get one to solder. And mainly because this area of the board, you've got to get it very hot. If you use hot air, the thing will blow away. So in the end, I did it with a soldering iron, just getting plenty of heat in on either end. So those two are fitted on there. The other one, this is also one of the larger ones, and I don't have it. I have a 0603, which is smaller than this. I'm pretty sure this is like an 0806. I have 10 microfarads in the smaller size, but they're only rated at 10 volts. And this is a 19 volt rail, so that's no use. So I will actually order some 0806 and the higher capacitance values, and just keep, you know, a few different values in stock at sort of 25 volts or more. So I'll have a look at those. The other thing then, so obviously this is where the power comes in, is the MOSFET and the resistor, which went AWOL, as you saw during the video. The resistor is a pull-up, so this is 19 volts, and it basically holds the gate high unless the circuit switches it low. I'm pretty sure if I just powered it from here, this thing would actually power up and run, but you wouldn't be able to switch it on and off. I'm pretty certain that's what this is for. And it's also likely it might power up before, you know, the SIO is ready to switch it on. So this is not budget and scram. I'm not going to stick 19 volts in there. Yeah, budget and scram electrical engineers know. If you, the way I look at it, do the job right, and if you don't want to wait for the bits to arrive, well, go somewhere else. Sorry, you know, I'm going to do this properly. So I need to order P-channel MOSFETs. I haven't got any, but at least the next time I come across something like this, I'll have something in stock that I can use. Yeah, so that's what we need to do now. But you can see. Now we'll just take the voltmeter so you can, so we get to this shot, yeah, probably sideways. So this is the 19 volts coming in where we had the short circuit before. You can see the meters on the resistance range. I'm just shorting the leads together. So if I now go to ground, you can see now we're reading like 390 kilo ohms. Yeah, so the short's gone, and I'm confident that's fine. I'm confident this will work after that. I don't believe anything else could have been damaged because the short was on the 19 volts rail. Okay guys, so I'll let you know how I go on with this. It'll take a little while for the parts to arrive. I'll just call the customer now and just say, oh, I'm sorry, you have to wait a bit. And yeah, I hope you enjoyed that. I know people are asking me about voltage injection, and I think this is a very good example, because really this shows you where voltage injection alone doesn't really help you. Yeah, but with the millivoltmeter, it was a good technique, and the fact it got slightly warm helped us, but we could have gone around anyway and found this area, you know, by the method I used. Alright guys, hope you enjoyed it, see you all soon, and ciao for now.